Setting a reorder point determines the service level. But if somebody gives you a reorder point, how are you to know what that service level is? You can see that situation shaping up here. Adventure Center sells bottled water throughout its park. When the Adventure Center Central Warehouse orders a new shipment, it usually sells an average of 1,500 bottles from its existing stock while it waits for the newly placed order to be delivered. Now, wait a minute. Why am I underlining all of that? Because setting a good reorder point is all about demand during lead time. And what I just underlined here in orange was a very important statement about demand during lead time. This, where it says sells an average of 1,500 bottles during lead time, we just found mu, DDLT. The mean or the average demand during lead time. Right, this image down here is pre-printed in the note frame. It's a normal distribution. All right, another little footnote in reorder point analysis is that the traditional assumption is demand during lead time when it fluctuates is normally distributed, which is why a bell-shaped curve was copied into this particular note frame. What we just found was one of the important parameters for identifying the exact normal distribution that describes demand during lead time for bottled waters at Adventure Center. Its average is 1,500. Oh, all right, now we're not even done with the paragraph. Let's go back. This demand during lead time varies, yes, we know, according to a normal distribution. Oh, we were just remarking, with a standard deviation of 200 bottles. That is the other thing that we needed. Because you can completely describe any normal distribution anywhere if you know its mean and its standard deviation. Oh, and so the normal distribution that describes the variation in how much bottled water you need during Adventure Center's lead time, we just captured it. The center is 1,500, standard deviation is 200. See, all right, I got that. Now, wait a minute, like, what's the question? Adventure Center had been reordering. 1,500 bottles were left in stock at the warehouse. Oh, okay, but it is considering increasing the reorder point, that's what ROP stands for, to 2,000 bottles. Oh, so this is a proposal right here. Perhaps we should do this. Reorder when there's 2,000 bottles left. What's the question? What are the safety stock, service level, and stock out risk associated with this policy that they're considering? Now, as long as I am relating everything that we're finding so far to this drawing, I can continue to do that. Because this right here is a good illustration of the proposal. This normal distribution represents different levels of demand during lead time that generally average out to 1,500, right, in the center. The height of the curve describes the likelihood of a particular level of demand during lead time. What's being proposed is that you reorder at 2,000. Why is that a good picture of the reorder point? Because we'll reorder at 2,000. Anything to the left on this picture is a lead time in which the actual demand for water bottle was less than or equal to 2,000, which means good, right? We had enough. And then anything to the right is a particular future in which demand during lead time for bottled water happened to be more, right? It's a number line. Oh, meaning that we would have run out because we only left 2,000 bottles in stock. We have a perfect image of, now you can see that, service level. That's the entire area to the left. This is every time that this worked. And stock out risk. That's that part that got excluded because we decided, fine, we're going to go ahead and we're going to reorder here. Now, that's what they're asking about up there. I mean, we've got an illustration, but we don't have numbers to attach to this exactly. Oh, all right, so we're going to evaluate this particular policy of reordering at 2,000. That first question is really easy. Let's just go ahead and answer it. The safety stock is nothing more than 2,000, the reorder point, minus 1,500, the average demand during lead time, or 500? First off, if Adventure Center starts reordering when there's 2,000 bottles of water left in stock, we say, oh, well, you know, that is a safety stock of 500 bottles. Because safety stock is any difference between, on average, how much you need during lead time and what you actually reorder at. It's basically by how much you're padding the long-term average to actually use as a signal for placing your order. Right, simple arithmetic. This part is the reorder point. This part is the average demand during lead time. Oh, okay, great. Got that one done. Now the service level. What is the exact service level here? Oh, all right. Well, we were saying that in the illustration, this whole part of it in here represents service level. Because, wait a minute, definition for service level. Service level is the probability that demand will not exceed supply during lead time. Service level is the probability that you'll have enough while you wait for the new order. Oh, so if we could figure out, if you take the normal distribution that reflects every possible thing that could happen during lead time, and you slice it right at 2,000, the proportion of it that is to the left is analogous to the probability that we would be there the next time that we place an order, which would be the probability we'd have enough, which would be the service level. So the only thing that we need to do to answer that next question is we just need to figure out exactly how much of the curve did get cut off here to the left when we drew a line right at 2,000. So I wish I had a table that told me, given that you slice the curve at a certain point, how much of the curve is to the left of that point for a normal curve that has a mean of 1,500 and a standard deviation of 200, because that's the curve that we're working with and that we care about. Well, we don't have any such table that reports that information to us. Okay, but practically every business analysis textbook that was ever out there in the back has a copy of the standard normal table. Standard normal. And if you printed out the note frame that I'm using, you too have a copy of the standard normal table. Because what is a standard normal curve? A standard normal curve is a normal curve that specifically has a mean of 0 and a standard deviation of 1. And you're thinking, well, that's a curiosity, but why do I care? Because you can convert any curve to a standard normal curve quite easily. And then what's shaded here? The area to the left of some point of interest. Now the point of interest on the actual standard normal curve is labeled Z. And the way to translate your curve into a standard normal curve is to complete the formula for a Z value. That's what I just wrote here. And you go, okay, wait a minute. A formula for a Z value. What's that? Pretty simple. The X, for instance, is the number that you're interested in. And in our case, it's 2,000, right? That's that reorder point that we're looking at, right? In our curve, that's actually what this line is. What's mu? That's the mean of our curve. Okay, well, that's 1,500. And then divided by sigma, that is the standard deviation of our curve. Fill this in, right? And that will translate this spot from 2,000 to the particular value Z on this curve that we could look up on this table and find out what it was that I was trying to shade in here. Oh, all right. So anyway, so that means I've got to do these calculations. That's what? 500 divided by 200, which, what's that work out to be? I get 2.5. Right, 500 divided by 200, I get a Z value of 2.5. And you say, oh, all right, is that, we were looking for service level, is that the answer? Not quite, but we're almost there. That is the means to look for the answer. That is the address of the answer, but the 2.5 isn't the answer itself. Because on a standard normal table, you look up the first two digits to find your row, that would be 2.5. And then the third digit, which is the second decimal place, to find your column, which, well, it's 2.50, so we're in the first column here. I said, oh, all right. Well, I'm trying to find that. That's way down there on the bottom. Yes, it is. It's true. But it says 0.9938. 0.9938. I have to remember that number. 0.9938. 0.9938. Why? Because we just found out that on this particular curve, when you cut it right here at 2000, 0.9938, 99% of it is to the left. That's the service level. Service level. That's the service level of a reorder point of 2000 here. Basically 99.4%. We normally speak of service level in percent, not decimal places. So I'm taking the 0.9938 from the table and I'm just rounding to one decimal place, but so it's 99.4%. Oh, now it's also asked what's the stockout risk. Having found the service level, the stockout risk is a breeze because this is the service level, so the stockout risk is just the opposite of that, right? Or it's not very much at all in this case. What? Let's see, stockout risk. What is the opposite of 99.04%? 0.4%? We've got like what? 0.6%? So we have just discovered that if Adventure Center reorders bottled water when there's 2,000 bottles left in stock, that's the reorder point, there is 0.6%, there's less than 1% of chance that they're going to stock out before the new shipment of bottled water arrives.